answers, what I at least I did to solve it would or was to check if they did
Okay, so
substitution.
that's fine. I'm just clarifying that there is nothing in
Yeah,
this justification problem.
yeah.
Okay,
There's and
so that's fine. Okay, so now, okay, so you do that, whatever. That none of these are all like algebraic steps. So uh that's where you're trying to decide here. So like I said, one way is to like go and look and like see like, is there a substitution at any point? And there looked to be one right here where y plus x goes to c. That
yeah,
looks to be substitution. Okay, so that one's in there, so that's out. All right, now addition property of equality. Okay, so we're looking for things that add up. Transitive property of equality, that's if A equals B and B equals C, therefore A equals C. And the distributive property is
yeah,
something on the outside. So it's like, I don't know, C times X plus Y equals CX plus CY. All right, so again, probably good to kind of figure out if there's like which ones are going on here. Like now the distributive property of equality backwards is sort of, and that's like factoring. See how there's a CY and a CX and you're factoring out the C in this
yeah.
step here to this step. Like I would call that a factoring, but that would, I would want to look at your book real closely, your notes, and be like, well, is there a, did they call that like distributive property because you're just undoing it? Or not? I really don't know. That's okay. But for example, here we know that and I know we're just sort of jumping around here. So a squared is cy, that's here. B squared is cx. So that's where they got this. A squared plus b squared equals cy plus cx. So the b squared, again, that's a substitution thing. So we know that's definitely not in there. I'm looking for an addition property of equality. I'm looking for some sort of like two things add up together. I'm not really seeing, I'm also not really seeing the transitive either. A squared. Okay, if that leads to that, that leads to that. Okay. So I guess I would probably rule out distributive property because of like what's going on here, because it's either transitive or addition. We are adding a bunch of stuff.
I feel like addition property of equality would be there, but
I'm not sure where though,
see,
because it normally it's you would show the cumulative sum of two things. I'm really not seeing transitive. I'm really not seeing A equals B, B equals C, then A equals C.
yeah, there's not any of that in there.
I definitely don't think there's anything close to that. If A squared equals CY. And so we're looking for somewhere where like CY equals something, or B squared equals CX and then CX equals something. So A squared plus B squared equals, where is A squared and B squared in this? A squared, okay. So what I'm missing here is it's like, are they just setting A squared plus B squared equal to itself at some point? CY plus B squared. Hmm. Okay, I guess because you're continuously working on the right hand side. I just don't see addition property of equality. I do see, I'm sorry. I don't see transitive property. I mean, you're adding all over the place on the left. So addition property of equality is when but you would like add to both sides typically. So this is like an example. You'd be like x minus 4 equals 7. And then the next line is x equals 11. That's the addition property of equality. Like, I don't see that though, truthfully. Like, I don't see that they're subtracting out. Transitive property I also don't see. Maybe it's up here. BC equals A. maybe they're using transitive in the sort of this like a thing here. You know, I'm not sure, truthfully. Now you've not submitted this or you have?
I have not,
You have not, okay.
although it is due today.
Okay, yeah,
Like,
so let me see if I can find it, just to sort of prove to you the addition property of equality example is not here. But let me see if I can show you that. Although it's just that's why I was kept asking if they. So it's like what's going on in this step here? They're multiplying both sides, and then they're writing. Oh, there's the addition property. There's the addition property of equality. Okay, there it is. Okay, sorry. This is the addition property of equality.
got it.
Okay, although I don't really like it, but that is definitely it. Distributive property. My question is, can it go backwards? Because I don't think there's a factoring property of equality. So I see it. I see it. Yeah, both directions here. So this, even though I call it factoring, it really is the distributive. If you go
Yeah,
either
that's right. That's
direction.
what I kind of saw as well. Yeah.
So I guess I'm
Look
going to
at
say go with transitive, or the fact that it's not there, but because the other ones are there.
All right. All right. So, yeah. All right. Let me put the next one. It's number 3. One.
So you drop something in the chat here. Take a look here. Save that. Okay. Well, sometimes the classes get rid of proofs for the second semester, so this may be the end of it if you can endure just a little bit longer here. All right, so which statements accurately complete the proof? All right, so let's see here. DE is parallel to AC. I thought we did one like this. So AB is a transversal. So is BC, by the way. And we're trying to prove the side, we're doing the side, similarity. Okay, so we know that this angle here is congruent to this angle here. So that's, I think, reflected here in angle BDE congruent to BAC. There it is. And then similarly, that's down here. Now they're corresponding angles. Okay, so that's the only one that says that. Let's go a bit further. All right. We know that angle B is congruent to angle B. That's great. And then we do have to prove the triangles are congruent here in 5. That's necessary. So you're looking for one that has a triangle there. And we've got 2 angles, AA. We've got the B angle, and then the one we just proved here in first step. So that one looks to be correct there.
All right. That's right.
Is that okay, or do you want more explanation on that?
Yeah. Got it. All right. Okay. Let me put Alright, it's in the chat.
Okay, there it is. All right, new problem here. All right, so we got two overlapping triangles. Sometimes it's good to draw them separately so that you can see just the triangles without the overlap in them. Which fact is not used to prove that ABC is similar to DDE? Okay, so just like in the previous problem, the segments have to be parallel. That has to be the case because then you get a transversal. That's the next one. Okay. And then angle B is congruent to itself. Well, it's the same angle in both. It has to be congruent in itself. So you got to hear this is the correct answer for that. It's actually very much the same as the previous problem there.
Alright, and then there's one more in this that has to kind of go over because I haven't done this one problem yet. Kind of
Okay.
confused on what to do for this problem.
I like
So
that you're
it's
trying them
this
out on your own. That's a good thing.
in the chat. So this one I haven't done, but yeah.
Okay, that's all right. Yeah, you're welcome to use our time together to work on, anything you want. So, all right. I mean, this is the more generally we're looking at the small triangle, the medium triangle, and the large triangle. Now, one of the things I think could help here is that this is really y squared equals xv. This is y squared equals wz. This is y squared equals w times w plus z. Y squared equals z times w plus z. Why is that important? Well, y appears in two places. It's both the long leg of the small triangle, and it's also the short leg of the medium triangle. Okay, so why does that matter? Well, I'm gonna need this area of the screen, so I'm gonna just move this down.
Okay.
I'll get this down. No, come on, don't do that. There it is. Okay, so there's a proportion here that's being set up, and y appears in two places. Okay, and it is in the small triangle, it is the long leg, and in the medium triangle, it is the short leg. So this is where you have to fill in the other intersection. You have to fill in what is the short leg of the small triangle? Can you tell me what you see for the short leg of the small triangle?
The short leg of the small triangle is W, side W.
W there, yep. And then there, the long leg of the medium triangle. What is that?
Z.
Z. And then you're just cross multiplying here. Y times y is y squared equals W times Z.
Got it. Yeah, I think that kind of makes a little more sense. I was at first wondering what the I equals. I was trying to kind of figure out that. Yeah, that kind of makes sense now. So you put y over the shorter side of the smaller triangle, then the larger side of the medium triangle over y to get the expression for y. Got it.
The way I've set it up here is not the way it's taught, but it works really well to organize things in a table. What you have, what you don't have, what you want to have, what you wish you had. Maybe you can find it.
Got it. All right. So that's it. For that lesson. Next one I'd like to go over is 3.3. And in particular, number 5. Let me do a screenshot of this.
Right there it is. Right, Jamal drew triangle LMN in which measure of angle LMN equals 90. Right, so we gotta draw this. And it's okay if you don't know how to draw it to start. You just try something. Hopefully it works. M is right here. We don't know where L and N go. Like they could be flipped, but M is definitely 90. That's where the middle vertice. Now, it says that triangle PQR is a dilation of triangle LMN by a scale factor of 2 from the center of dilation at point. So it's right there. And of course, I haven't given myself enough room to do this, but what that means is it got bigger. Everything got doubled, basically.
Yeah,
Because
so
it's
this
from
stuff
that point. Yeah. So there it is. Okay. Which of these can be used to prove triangle LMN congruent to PQR by the AAA? So P, no, sorry. E is up here, Q, R. All right. So, I mean, we've seen this problem now a couple times. The lines are parallel. They have to be parallel. The angle is congruent. Okay. Let's see here. Angle R equals angle, and that is true, but is that needed? Okay. Angle P is congruent to angle, and that is definitely not true. Sometimes you just got to cross them out. P's up here, N's down in the middle. Those are not the same necessarily. Is that LM equal 2 times PQ? Is that what that's saying?
Yeah,
Okay. Well, that's definitely not true. It'd actually be the other way. It would be that
yeah,
PQ
because
is
yeah, it'd be like PQ is 2 times of LM.
right. But even if they had written it correctly, that's not helpful because you're trying to do AA. Do you only care about angles?
Yeah,
That's
so
another kind of test taking strategy, is to only focus on the things that actually are relevant, which is angles, not sides. So
so
now
that would
MN, good.
so that in that case it would also, yeah, I was gonna say that the last one would also be ruled out because the last one's talking about the sides as well.
Even if it was correct, it's still not helpful.
Yeah, because in this case we're talking about angling goal, a similarity postulate, which basically states that like the angles have to be congruent between the different to be congruent. So, all right, yeah,
So in real life, we often make arguments or discuss things with people, and sometimes we bring up stuff that isn't really relevant, and that's what these kinds of problems are. They're trying to show you what actually matters, and sometimes people say things that they just don't matter.
all right. I think it's yeah, let me put another one. All right, so this is a different lesson. This one was triangle congruence and similarity. So it's in the chat now, I think.
Okay, got it.
For this one,
Downloading.
I just kind of like to look over and make sure that it's correct, because I did look over it once myself, but Okay.
Yeah, now see how it says our triangles, DEF and LNM similar. One of the things that you would probably want to do here is reorient one or both of the triangles. So I'm gonna reorient this one here so that it matches. So L is at the top, N, M like that. So we have L, M. Okay, so I'm just reorienting it so it kind of looks like the one on the left here. Now it says if LN equals 5, MN equals 3, D equals 10, and FE equals 6. Is that enough? Okay, is that enough? So you can see that 5 goes to 10 by doubling it, 3 goes to 6 by doubling it. If you could find this, which I think will be something you'll be doing a lot of in the next part of the course, you'll find that it's the square root of 34. And this up here is 2 times the square root of 34. And it does work. It does work. So, but you don't need to do that. You just need to prove that 2 of the sides are the same, because by essentially no choice, the third side in a right triangle must also be the same. So yeah, this is but actually hang on a second here. I didn't see this at first. So I didn't see that there was SAS. Is there an SAS similarity?
Yeah, there is. I have it in my
Okay,
notes over here.
and that's
That's
actually more consistent because you got the sides and the angle between them.
yeah,
But
that says it too.
because
But
it's a right triangle, you only need, I didn't think you, let me double check this. Yeah, I mean, I actually think it is SAS, because to get the third side, you don't have the third side, even though you can calculate it using the Pythagorean theorem, which I did. That's not what it's asking you to do. So it's like, while you could use SSS if the third side was given, since it's not given, you've got to limit yourself to what is given, which is the side, the angle, and the side, angle, side.
um, so SSS, SSS. Remember to BS by SAS. Great question. All right. Number 2 and all right, number 2 is in the chat now.
Okay. Right. So name the similar triangles. This one is nice because they're both oriented the same way. So notice they all say ABC. And you just have to decide which one corresponds to A. Well, it's clearly D, okay, which gets you down to those two. And then, well, does A move to B? Yeah, so D must move to E. And so on. So remember, it's a path. It's a path. Good. It's good that you could get that on your own.
Your two's in the chat.
Right. There it is. That's okay. All right. This one, if you could cut it out of the page, like if you had it on physical paper, you would see that, okay, this triangle orients with the other one, where A is down here, B is here, and C is still there. All right, and I think sometimes that like you really want to look at them as if they're in the same orientation. All right, and then yeah, okay, then you label it. Now this time, see how they're giving you all three sides? They're giving you all three sides. That's really good. Okay, so that's probably the answer. Like see how the last two use SAS? Those are probably out because they're giving you all three sides.
Yeah, plus when I look back at my notes, and that's the first one is the one that kind of aligned with what the notes were saying about this type of funnel.
I would agree. And it is that it's not that it's that all three ratios have to be the same. So
Yeah.
the hypotenuse over the hypotenuse equals the longer leg over the longer leg
Yeah,
over the
that'd be
short
the
leg.
corresponding part set for both
Yes.
from both.
So it's not enough to show that just two of them are the same for SSS. They all three have to be the same.
Pretty much, yeah, every side on there has to be the same, pretty much.
Yes. And you might have seen this like in algebra, your algebra class, and you did some sequences where everything, all the ratios had to be the same.
Yeah. All right, I put number 4.
There it is. Which of the following best completes the proof showing triangle XYZ proportional to, or WXZ proportional to XYZ? So WXZ is the medium triangle, and XYZ is the small triangle. Okay. So first of all, you're looking for proportions that actually are true. Like this second one is not true because that doesn't work. Same with this last one. So, I mean, there's this, I can't believe they're actually doing those, but they probably had hard time coming up with the answer to those. But now you just got to figure out, okay, like what's going where, and you can see they both have the same set of numbers. So you just have to get that, figured out here. Let's just go with the one that you think is right. Okay. For the moment. So what is 10? 10 is in the medium triangle. It's the long leg. And then 5 is the short leg. And then you'll notice that I labeled small triangle over here because that's the other one we're interested in. What is the long leg of the small triangle? Well, it's 5. And the short leg of the other triangle is 2.5. So I agree with what you've selected here.
So for 5 in the chart. Yeah, I think it, yeah, just put in, so it's in the chat now.
Okay, there it is. All right, so we're trying to determine the length of segment AB. So where is AB? So it's this other triangle here. So AB is going to have a relationship to other stuff. And it's kind of like, are you going to use, well, again, like 2 of these are just gone. That's not enough here. You're going to use the relationship between 2 triangles. Like AB goes along with AX. Okay, but you got to be careful here. Like you notice I've been doing this kind of where I'm putting this is now like the large triangle. And it's now going to be the small triangle. And then you gotta, it's like sides one, sides, left, I'll say, sides maybe right. So like AB is the left side of the larger triangle. AX is the left side of the smaller triangle. So do we have the right side of the larger triangle? Yeah, that's A to C. Do we have the right side of the smaller triangle, which is AY? And then we're solving for AB. So AB, you just multiply both sides by AC, this bottom here, and you get AX times AC over AY, like that, like you've done there.
Got it. All right. There's 6 here. All right, I put it the
All right, there it is. Okay, so finally a numerical problem, probably a relief to finally something like that. So it's a ratio of 3 to 2. So there's a couple of ways to do it. 3 over 2. They want you to, they're giving you BC as 24. They want XY. So it's we know it's smaller, but it's like, well, how much smaller is it? And it's to go from the smaller to the larger, that it's 3 2 3 twos or 3 halves. To go the other direction, it's the reciprocal. So to go that way, if you want to go the other way, it's 2/3. So 2/3 of 18 of 24 is 16.
got it. Next, 7. So, yeah, forget the chat.
Okay. All right, so another more triangles. All right, B is the midpoint of AC, which best describes the relationship between triangles ABD, and CBD. Okay, CBD, there we go. Okay, so since it's the midpoint, we know that those are congruent for sure. And this other side is reflexive, so it's congruent to itself, which means that you've got an SSS thing going on because all 3 sides are congruent. So that means you're down to the first 2. So I guess the thing is, can you prove congruence? Yeah, they're exactly the same. They're not in a ratio.
Yeah, because they probably would be actually, yeah. That makes sense. Number 8 in the chat.
is. Right. Right, triangles, EFG, triangle LMN with a ratio of 2 to 1. Which of the following is true? Okay. Probably good to draw them, you know, just something. EFG, triangle LMN, like that. So EF is in ratio to LM. And whatever that ratio is, it has to be the same as like FG now to MN. Okay, so EF over LM EG. So I was looking at one of the other ones, but like it doesn't have the right letters for the sides. So this one is correct. The other ones, they're not congruent, so they can't be.
Got it. Yeah, that makes sense. Got a benefit on identify. This one, when I did do it, I accidentally tried to put an X as the answer. You'll see it when we go over it, but then I luckily didn't like submit it then, but then I went back and plugged in X and got the and I got one of that there. So yeah, this is the problem.
New bridge structure requires a triangles in a ratio of 1 to 1. AC is 4x minus 3. And EC equals 2x plus 6. Find the distance between the top and bottom of the bridge in feet. So I mean, again, probably best to draw it without all the stuff. Okay. This is 4x minus 3. This is 2x plus 6. They appear to be congruent. They share an angle, and then these angles are the same. So angle means they're similar, and they're similar in a 1-to-1 ratio. So you can just set them equal. All right. So we got X ends up equaling what, 4.5, but you now have to put that back in to one or the other and then double it. So 30 is probably correct, because when you put this into 1, you probably get, well, maybe you don't get half. So 4.5, 4 times 4.5 minus 3. That's 10.5. No, 9.5. That's not right. What did I do wrong here? 2x, 9, x is 4.5. No, 15. Sorry, total. That's okay. Sorry, I just totally messed up. Yes, that is correct. Each of these are 15, like that.
Got it. That's what I got when I did it, but I accidentally tried to put 4.5, which you see is one of the answers of that's available there at the top. But then I forgot. Yeah, then
That's a
I forgot.
common wrong answer. The intermediate step.
Yeah, I forgot to plug it in, and then once I plugged in, and I got 30 after I added it above the 15s. All right, then finally there's number 10.
And they go to a lot of trouble to make these pictures for just triangles here. It's really, it's just a tiny bit smaller, so it'll fit on the notes. All right, an aerial camera is suspended, hangs in an altitude 25 meters. Okay. So the camera hangs 10 meters below the blimp. The blimp is attached 20 meters in length. How much ground distance from A to C can it cover? All right. So why don't you tell me what you did here? What did you do to find this answer?
So for this one, it tells you that it hangs at an altitude of 125, and that the camera hangs 10 meters. Like the altitude of that smaller triangle at the top is 10 meters. So what I did is I found the ratio between the 125, and 125 divided by 10, and then I got the 12.5. That's the ratio between that, and then after I got that, I multiplied that by 20 and then once I multiplied that by 20, I got the 250.
Good. That sounds correct. Yeah. I mean, they're in proportion, so you got it.
Yeah, I was a little bit stunned for a little bit, then I kind of figured out that you have to find the ratio between those two given I just to find like the ratio between the two sides. All right. There is just quickly. All right, so let's see. So this one was more like a quiz lesson, I guess, but uh here, let me go to one question back. Numbers have been
Yes. All right, so let me get that going here. Save. Too many button clicks. There it is. Ooh, okay, so this one we haven't seen something like this yet. But theorem, a line parallel to one side of a triangle divides the other two proportionally. Okay, which statement can be proved through using the given information? Okay, so it's you got to be careful here which ones you're looking at. It's either triangle ADE, this one up here, or to the big one, which is ABC. That's option one, or it's triangle CEF to CAB. All right. And sometimes it's good to like label them. So like this is 18 and 30, and this is 24, and then AC, we've got that already. That's 30, which we don't have down there, but we know that AD is 6, and that's 12. DE is parallel to segment. Okay. So segment, so basically just gonna go one by one here. Can we prove that BD, where's BD? Okay, BD is that 12. The only way we can do that is if we know that the ratio from, we gotta look at one of these other ones, like how do you go from this to this? Or 18 to 30. So like to do that, you're multiplying by like 5/3. Yeah, 5/3. So that means you'd be multiplying BD. Where's BD? There's BD. Okay. So the problem is BD is kind of this, like you want to know the whole length. So or so to go from like 12 to 30, we're multiplying by 5 halves. So if we multiply 6 times that, that's 5/2, that would be 15, which would make it 9. We are running out of time here, so I'm suggesting it's probably not that. But go the other way, 5/2, 24 times 5/2 would put you at 126. 18, that's not right. 5/3. So that would put us at 40, and that's 16. So this is probably the correct answer. And unfortunately, we just are out of time
All
to be
right.
able to go through it much
Yeah,
further.
but this isn't due till tomorrow, so we can